Hey guys, week 3 we're going to continue practicing chemical reactions and predicting products. Last week we did a single replacement reaction, and in week 3 we're going to look at a synthesis reaction, otherwise known as a combination reaction. By definition, this type of reaction, a synthesis reaction, is when two or more substances react and they form a single substance. The generic form is when you have two or more substances. Here they are right here. These are the ingredients, otherwise known as the reactants. And they go through a reaction. Sometimes it requires a little bit of heat, and they will form one substance. We know that there is one substance on the product side because there is no plus sign over here. So an example of a synthesis reaction, and you'll get to practice a few more of these for this week's assignment, is if let's say you take some magnesium, which of course is a solid, and let's get it to react with oxygen gas. And what we have to do is add a little heat to this. I did this in class. This is the magnesium ribbon strip, and I ignited it so that way I got it to combine with oxygen. And then when I simply put those two things together, I get Mg, and that's a +2, and I get an O, and that's a -2. And so the correct formula would be MgO. Notice that even though it's O2 over here, because that's a diatomic element, I don't write O2 on this side. I have to crisscross and reduce the charges to get the correct chemical formula for this product. You'll also notice that it's not balanced now. So to balance it, with two oxygens on the left, I need two oxygens on the right. And by default, that changes the number of magnesiums, so I have to balance it over here with two magnesiums. So that's our first example of a synthesis reaction. The second example of a synthesis reaction is taking something like potassium, which is a solid, and reacting it with iodine, which is also a solid. And if I put those two together, I'm going to get something called potassium iodide. Now the charge of the potassium is a +1, and the charge of the iodine is a -1, so therefore the correct formula of potassium iodide is just simply Ki. Even though I2 is over here, it doesn't mean it's I2 over there. Once I balance it, I'll have two iodines on both sides, and then I'll also have to balance it with two K's over here. So these synthesis reactions are pretty simple reactions. I'll show you one more example, and then you'll have some practice to do. Real quick, shouldn't take you that long. Let's take some sodium, which is a solid. It's that soft silvery metal that I showed you. And we'll combine it with some deadly chlorine gas. Okay, this was used as a in the gas chambers in World War II. Kind of morbid to think about, but when you take an explosive metal and you react it with a poisonous gas, what you get is sodium chloride. And if I crisscross those charges, I'll see that that is actually NaCl. To balance it, I do the same thing. These three examples are kind of balanced very similarly, but that's not always the case. So those are single replacement reactions. It's a short video this week. I don't need to review about how to balance equations. If you've got questions, make sure to get in touch with me through email at amstutza@manistee.org, or you can text me safely through Remind, or you can also go to our Edmodo. Okay. Also, completing these assignments can greatly impact your grade. Not greatly impact, I should say, but it will give you a chance to raise that grade. If you weren't on track to passing the class, completion of these assignments can also lead to a passing grade and only having to take chemistry once. So, if you've got questions about these synthesis reactions or anything else, make sure to get in touch with me. Otherwise, good luck.